Hello student, in this video we will be discussing about joint probability and conditional probability. In this topic we are going to be discussing about the joint probability, also called conditional probability. Up to now what we are discussing is probability in one dimension. The meaning is either we are discussing the at the input side, means at the transmitter side, or maybe you are discussing with the receiver side. But now as a whole communication system means you need to combinedly study about the input and output, that is transmitter and receiver. Then the concept of this joint probability or the conditional probability came. Are you getting my point or not? P of x means input side, P of y means output side. Now here xy means we are calculating the joint probability, or we can also say the probability of a whole communication system also we can call. For example, students, I am having one set. Let's take some S1. It is having some x1 like x2 like x3 x4 and so on. Some xm number of symbols are there, like, and so on. Like we are also having another set. This set is called some S2. It is having the symbols like y1, y2, y3, like, and so on. Yn number of symbols we are having. Now what we are discussing, like we are discussing separately about them, then we can call one dimensional probability. Now what I am discussing, or maybe the transmitter and the receiver will call. Now what I am discussing is the combined probability or the joint probability. Combined or joint probability means like x1 y1, like x2 y2, x3 y3, like, and so on, xm yn. Are you getting my point or not? So this is the joint probability, yes, where S is nothing but S1 into S2. Are you getting my point or not? Here you can also give the numbers. X equal to 1 to m symbols are there, na? So simply xj, where j is from 1 to m, where j is from, once again, 1 to m. Here you can call this is a yk, of course, where k is from 1 to n. And that is their combined one. That is, you can also call them xj comma yk, where j is from 1 to n, k is from 1 to m, k is from 1 to n. This is their joint probability things I given. Where xj is the any element in the S1 set, where yk is any element in the S2 set, where here xj anyone with the yk is the combined set in relation with the both. In relation, for example, xk is relation with the yk, or yk is relation with the xj. That is the combined set I taken as a sum yes. Now here what is my intention is I need to calculate the joint probability matrix, as well as I need to calculate their joint entropy. For the joint probability matrix, we need to calculate the entropy also. So what is the complete joint probability matrix set? Can I write? Or for example, if you want the complete, what is the input matrix? That is nothing but x1, x2, and so on, last symbol xm. I already told that. 1 to m. What about for y? So the complete set for y is nothing but y1, y2, y3, and so on, yn. Then what is the complete set for This is the complete set for S, that is xy equal to P of x1 y1, P of x2 y1, sorry, one second, y2 x1. So probability of x1, y3 and so on. The last symbol, probability of x1 into yn. So completely, if you see, the first row is completely for x1, may be received as a either y1 or y2 or y3 or y4 or and so on yn. So this is the complete set regarding x1, may be received as any one of the symbol here. Like second row corresponding x2 y1, probability of x2 y2, probability of x3 y3 and so on, probability of, I am writing a mistake, second row is corresponding to x2 only, x2 yn. So complete second row is for x2, like and so on. What is the last element in input side? xm. So probability of xm y1, probability of xm y2, probability of xm y3 and so on, probability of xm yn. That is the last one. Sorry, from here onwards. This is the complete joint probability set. If you take the summation of that is a summation, the total joint probability matrix value will get as a 1. Are you getting my point or not? Now, here we are having the 3 sets. One is P of x, P of y and P of xy. So, xy comma you can write, or directly xy also you can write. Now we are having the 3 entropies corresponding to these 3. So what is that entropies? The first one is h of x. What is this? The average information per symbol at the transmitter. H of y, the same but at the receiver. What is h of xy? Is a conditional entropy or the average information of the whole communication system. The average information of a whole communication system. This is at a transmitter, this is at a receiver. Now we'll write their corresponding entropies. What is the h of x? We know the formula, minus summation I equal to 1 to m p of xi, sorry, for j I taken, so j equal to 1 to m p of xj into log, I written already minus, so in the numerator you can write, base is 2 only, p of xj. This is the average information per symbol at the transmitter. X means transmission side. What is h of y? H of y is nothing but minus summation k equal to 1 to n p of yj into log yk into log p of yk. Now, here we can also write the p of xj is nothing but, it may be connection with the any of the symbol, that is nothing but, you can also write as a summation k equal to 1 to n p of xj yk. Means I taken k equal to 1 to n means it is a complete set. Any symbol in input side, maybe j value 1 if you take, that x1 in connection with the all output probabilities, means x1 may be received as a any one of them. So complete set I written. In a similar manner you can also write P of yk equal to summation j equal to 1 to m P of xj yk. Are you getting my point or not? Now, what is the joint probability xy? Joint probability is nothing but minus summation. Following my point or not? P of, there are two things are there, no? So summation j equal to 1 to m, summation k equal to 1 to n, P of xj comma yk into log of, already written minus, so log of P of xj comma yk, of course basis. That is the joint probability matrix. So where you can call them also h of y and h of x and h of y are the marginal probabilities of the system at transmitter and at receiver. This is the joint probability, or the average information of the whole communication system also you can feel. Clear? Let me extend this one and we'll get the formula for the joint probability matrix, or the entropy of the joint probability. Clear? See. So by mistake in the previous slide written joint probability or conditional probability, but not joint probability and conditional probability. Both are different. So up to now what we got? I already told h of x and h of y are the marginal entropies. Marginal entropies at the transmitter and the receiver, where P of xy is the joint probability. Now we are calculating the formula for the conditional probability. Conditional probability formula. How to calculate the conditional probability? Or finally, I will give the entropy for the conditional probability also. What is the conditional probability? Let's take P of x by y or y by x. Anything you can take. It's not a matter. What is this formula? P of xy by P of x. Sorry, P of y. Let's take, what is the meaning here? Let's take one element yk. Yk in connection with any element at the input side. Any element means like x1, x2, x3 and so on, xm, the last symbol. Are you getting my point or not? So what is the meaning here? One symbol means if we are transmitting any of the symbol here, may be received as a yk. So yk connection with any of the symbol I written. So let me write that probability matrix, or the probabilities first. Later we can write the matrix. Let me write the complete set of them. The all symbols in connection with the yk, I am writing a complete set. So P of x by yk is nothing but, what is that complete set? X1 by, let me write the not probability, complete set first. So matrix I am writing. So x1 by yk, x2 by yk, x3 by yk, and so on, xm by yk. Are you getting my point or not? Now follow. Then what is the probability x by yk? The probability matrix is nothing but probability of x1 by yk, probability of x2 by yk, probability of x3 by yk, like and so on, last one xm by yk. This is the complete probability set I given. Are you getting my point? This is a complete, for all inputs may be received as yk, the complete probability matrix I given. This can also be written as a y1 by xk. You can see the formula. So this is nothing but joint probability of x1 with yk divided by probability of yk. What about this? Probability of x2 yk divided by probability of yk. This is probability of x3 by yk divided by probability of yk, joint probability of xm yk divided by probability of yk. Are you getting my point? Now, what is this complete set value? This complete set probability is nothing but 1. The meaning is, let's take the channel is a lossless, not a noiseless. The channel is a lossless. The channel is lossless means, if you transmit the symbol some x1, it may be received as any one of the output. So it's completely receiving means its probability is 1. Its probability is 1 means its complete set probability is 1. So from there, what you will get? You will get the probability of x1 yk plus probability of x2 yk plus probability of x3 yk and so on. Probability of xm yk, its value is nothing but probability of yk, because the whole value total probability is 1, so this is equal to that one. Clear? Now let's go forward. We are writing the conditional probability of the, we are writing the entropy of the conditional probability. That is h of x by yk is nothing but minus summation j equal to 1 to m probability of x by yk into log probability of x by yk. Now follow. This can be written as a minus summation j equal to 1 to m. What is this? P of x comma yk divided by probability of yk, getting my point, into log, I kept as this, probability of, or if you want, x comma yk divided by probability of yk also you can write that. This is the entropy of the conditional probability. Are you getting my point? Now, this is associating with a symbol yk only. This is associating with the symbol yk only. Now, I am writing the average conditional probability of a whole system. Whole system means whole symbols of y also has to be taken. Whole symbols of y also has to be taken. Then the entropy h of x by y, the conditional entropy x by y is nothing but, is minus already there right outside, summation k equal to 1 to n p of yk into whole the thing I am writing into h of this value x by yk. This minus lost in the previous I will substitute later. What I am doing here, I am taking the average entropy of the whole system. Here only for one symbol yk and a particular I taken, here for all possibilities. Now substitute this value there, then it will be minus k equal to 1 to n p of yk into, what is this value? Minus already written outside, summation j equal to 1 to m p of x comma yk divided by p of yk into log P of, I can write as a simply x by yk, let's kept as it is, or like that also you can write. Now if you see this one, it can also be written as, see, write the both summations outside, k equal to 1 to n, j equal to 1 to m, or first j, next k, anything you can write, into, if you multiply these two will be gone. What is this? Probability of x comma y, let going for a combined thing, into this one, log p of x by y. This is for all. So average of the whole system I am writing. So finally, what is the entropy or the conditional entropy of a system is k. Summation, first I am writing j equal to 1 to m, next k equal to 1 to n, p of x comma y into log p of x by y. In the similar fashion, you can also get the conditional entropy, that is y by x equal to minus summation j equal to 1 to m, k equal to 1 to n, p of x comma y log, base is 2 only, p of y by x. So finally these two are the entropy formulas of a conditional probabilities, or the average. Entropy means average information also you can say. So the whole discussion what we done is for the deriving the formulas for conditional entropies. For the conditional probabilities we got the conditional entropy formulas. So try to remember at least these two formulas. The remaining derivation is not that mandatory. Remember these two formulas, then we will forward for a different problems. Clear? Yeah. Follow. There are 5 entropies combination with the 2-dimensional thing. What is that 5 entropies we got? One is h of x, one is h of y, another one is h of xy, another one is h of x by y, another one is h of y by x. What is the meanings of those who will see? What is the h of x meaning? H of x meaning means average information per symbol at the transmitter, average information per symbol at the receiver, average information per pair of the transmitter and the receiver, or you can also call it the conditional probability of a whole communication system also you can call. The conditional probability of a whole communication system. Now, what is this h of x by y and y by x? You need to understand. Always the meaning of denominator is, that is known first, the meaning. What is the meaning of h of y by x meaning is, here the received symbol is yk, maybe connection or maybe transmission of any one of the xj symbols. Means it is nothing but we are measuring about transmitter by knowing received symbol is y. By knowing received symbol is y. What about this? We are measuring about the receiver by knowing that transmitted is xj. We are transmitted is x. The meaning is here, we are measuring about the transmitter by knowing the output. That is received one. We are measure of output by knowing that transmitted is input, that is x. This is will give you the noise or error. Now we'll also bring out some more relations between those in the following manner. Let's see. For example, h of xy, the joint probability. What is this? Summation j equal to 1 to m, summation k equal to 1 to n, k equal to 1 to n, p of xj comma yk into log base 2 p of xj by yk. Or first let me write for your way to make the confusion the same joint probability xj comma yk. Now follow. This can be written as a minus summation j equal to 1 to m k equal to 1 to n. Now follow. P of xj comma yk into log. This can be written as a how? Probability of xj by yk into probability of yk. I can write that. This is in the logarithm only. Then it is nothing but minus summation j equal to 1 to m summation k equal to 1 to n p of xj comma yk into this. You can write log ab. So log a probability of xj by yk minus log probability of yk. Sorry, ab na log a plus log b. Now try to expand this. If you are expanding this, try to see how I am writing is summation minus anyhow j equal to 1 to m summation k equal to 1 to n probability of xj comma yk into log probability of xj by yk. This one plus of course minus, yeah. Let me write in the down. Summation j equal to 1 to m k equal to 1 to n. What is that remaining? P of xj comma yk into log p of yk. Now what is this? This is nothing but what? The, what is that? The conditional probability. What is that conditional probability? Numerator is x. So x by y minus, try to observe this one. What is this in the previous way written? So we are keeping xj, but y we are taking from 1 to n. Or let me write more clearly. First I am writing summation k equal to 1 to n summation j equal to 1 to m. This you can see still more. You get xj comma yk. In the previous starting of the derivation, you can see what is this value I written as, not this value, into probability into log of probability of yk. And if you see this value in the previously what I written, the probability of yk I written. So substitute. So you will get h of xy equal to h of x by y minus remaining is summation k equal to 1 to n p of yk into log base 2 p of yk. Then this is nothing but h of x by y minus, this is nothing but entropy of a output symbol. So minus of that one. So plus hy. Entropy formula itself is minus is there. So finally h of xy equal to what you got? H of x by y plus h of y. In a similar manner, h of xy equal to h of y by x plus h of x also you can write. Are you getting my point or not? These are the two conclusions we can bring. So what is the final conclusions? You can one more time. What is the joint probability? This is the joint probability value already written. What is the conditional probability formulas? That is important. The conditional probabilities is nothing but, for the both I will write y by x as well as x by y. What is this? Minus summation j equal to 1 to m summation k equal to 1 to n p of x comma y, that is xj comma yk into log y is a numerator, so yk by xj. For this one, minus summation j equal to 1 to m minus summation k equal to 1 to n p of xj comma yk into log xj by yk. So these are the whole conclusions we brought. Getting my point? Now here I will show you, for example, if any channel is given, what is the input probability matrix, what is the output probability matrix, what is the relation between the both, from there from the channel how to calculate the conditional probability matrix, and from there how to calculate the joint probability matrix, I will show you. For example, I have one channel. Let's take the given channel is a lossless, and input side symbols are x1, x2 and so on, xm. Output side symbols, let's say y1, y2 and so on, yn, for example. The channel is lossless. The meaning is, student, whatever may be the symbol, if you transmit, it will definitely goes to output. But maybe it is received as a y1 or y2 or y3 or yn because of adding the noise. That we cannot know, but definitely it will comes to the output side. Definitely coming means probability is one, you need to understand. So that's why probability of x or xj into by yk, the whole summation if you take, that is nothing but 1 I written the previously. Now follow. And now this is a channel given. What is the input matrix means? Input matrix means write input probabilities in a order. That is nothing but, it's a row matrix. That is the probability of x1, probability of x2 and so on, last one probability of xm. Now follow. What is the probability y? Y also a output matrix, that is y1, y2 and so on, yn. Getting my point? So from the given channel, how to write the conditional probability? Let's take y by x or x by y, any your wish. What is the first element? The probability of receiving probability y1 when you transmit x1, like y2 when you transmit same x1, like and so on, yn if you transmit the same x1 symbol. Second row, probability of receiving y1 when you transmit x2. x2 is sent and measuring about y1. Like this is nothing but y2 when you transmit x2, yn when you transmit x2. In a similar manner, last one, probability of y1 when you transmit the last symbol xm. This is y2 by xm, probability of yn by xm. This is the conditional probability matrix. Now, channel is given means you can calculate the conditional probability matrix. So, input is given, conditional probability matrix is given. That can be written from the channel. Then what is the output, student? Output P of y equal to, how to calculate output? Output is nothing but the input matrix into conditional probability matrix. And what is the joint probability matrix? In the previously also I written. How to calculate that joint probability matrix? I will show you. That is nothing but P of x diagonal into P of y by x. What is P of x diagonal? P of x diagonal is nothing but P of x1 and so on. And let me write two more symbols, 0, 0 and so on. The last one also 0. Next, 0, P of x2, 0 and so on 0. 0, 0, 0 and so on P of x, last symbol is x. Means write the input probabilities in a diagonal form. Are you getting my point or not? This is the P of x diagonal. This is the relations. So if input and channel is given, you can calculate output, because if channel is given means we know the conditional probability matrix. From there, this is a relation to calculate output. This is a relation to calculate joint probability. And let me take a simple one binary channel is there. About all channels I will discuss. We are having one binary channel is there. For the binary channel, binary means two symbols only, input side. Let me call x1, x2. Output side also 2. Let's call y1, y2. For example, the probability of x1 received as y2 is p. Obviously, this is total is 1, so 1 minus p. Like x2 received as y1 is some q. Obviously, this is 1 minus q. Then, how to write the conditional probability matrix? That is nothing but y1 by x1, that is 1 minus p. Next, y2 by x1, that is p. y1 by x2, that is q. y2 by x2, that is 1 minus q. Number of times I will pronounce about one channel, that is called binary symmetric. What is the meaning of binary symmetric? Symmetric means if p value, q value both are equal, that is a probability of error for this symbol and probability of error for this symbol. Generally, you will write as a 0, 1. So, probability of error for 0 and probability of error for 1 is same. That is called symmetric. Why binary? Two symbols. About this one, I will get back. Just a simple channel I taken, and how to write the conditional probability matrix I show. Clear?